Live. Okay, so today's lesson really is, we call it system. Oh, hold on, the date is November 5th, right? So it's called Systems of Linear Inequalities. Math is full of all sorts of language. So let me put this into English for you, okay? So when it says systems of linear inequalities, systems means two or more graphs for us, okay? Systems means two, we'll say two graphs. We're not going to do more than one. Two graphs, that's the systems part. Linear means the lines are straight. They're straight lines, okay? And inequalities means that it's going to have the greater than equal to, or the less than or less than or equal to, okay? So what we have here is I've got an equation that I've got two, right? I've got two, some like systems, I got two of them, right? They are straight, they're linear, right? And I've got my shading because I've got my inequalities, right? So you can see, and I'm going to use my colored pencils, that on the first graph, and I'll do red, on the first graph we shaded less than, okay, less than or equal to, so it's all of this, see, y is greater than or equal to, so all of this is greater than, so that one's shaded that way, okay? Second one said y is less than x plus 2, so that would be shading everything under it. Now where I see they intersect, where the shading overlaps, is in this darker region in here, okay? So when I do these, I just make sure that that's darker than the rest, okay? Now, let's pick a point. Well, I'm going to pick a point where it works. So let me pick this point right here at, the point I'm going to pick is at -2, -1, okay? And I'm going to test it. It says test each point. So I'm going to test my, so the point I picked was -2, -1. I have a y is less than x plus 2. And I have a y is greater than or equal to 2x minus 1, okay? So this point is an answer. There's many. There's many, many, many. This is just one of many points. Okay? I mean, I picked this point here would also work, that point would work, but these points here wouldn't. This point would work for this graph, but not that one. The point here would work for this graph, but not that one. And the point way up here wouldn't work for either one of them, right? So let me show you what I mean, because sometimes you have to test these points. If I test my point, every point has some x and y value. So I put -1 in for y, -2 for x, and I just plugged it in. Plug into x and y. That's all I did. Plug my -1 for y and my -2 for x. I get an answer of -1 is less than 0. Is that true? Yeah, -1 is, so that's true. I'll put a T for true. If I test this region, I'll put the -1 in for y. I'll put the -2 in for x. So I took my -2 and put it in for x. My -1, put it in for y. I get -1 is greater than, well, that's going to be a -4 minus 1. Or -1 is greater than or equal to -5. Is that true? Is -1 bigger than -5? So I put another T for true. So if it's true for both, then yes, that point is the solution, okay? Now if I test a different point, for instance, if I test a point over here in this region, let's see this. 1, 2, 3, 4, 5. 1, 2, 3, that's at 5, 3. That one's going to work.
for the green graph, but it won't work for the red graph. And let me show you, okay? So I just want to test one region so you can see it'll work for one but not the other. So let me test this point. So my equations are my y is less than x plus 2 and y is greater than or equal to 2x minus 1. And I'm going to test the point 5, 3. So even just looking at the graph, I already know what's going to happen. But I want to show you, okay? Just look at the graph. I know it's going to work for the green graph. So I don't want to plug it into here, I'll get a true value. I will, because it's in the green area, right? I know when I plug it into this graph, it won't work, because this graph is not over here, right? So let me just show you the obvious. I'm just going to show you the obvious, that's all. So if I plug it in, first let's plug it into this one. Some x, y. I'll put 3 for y, 5 for x, and I get 3 is greater than 10 minus 1. 3 is greater than 9. Is that true? Is 3 bigger than 9? No. And we knew it wasn't going to work. We knew it wasn't going to work at all because that was the other region. But it will work for this region. Put 3 in for y. Put the x. Is 3 less than 7? Yes, that's true. So it works for one region but not for the other. So it's not a solution. It's not. And we can see it's not a solution because it only points that are solutions are these points in here. That makes sense? It's pretty easy, isn't it? You guys agree? Okay, now let's actually graph these. Okay, so let's graph these. So first of all, equation 1 I can graph right off the bat. Call it equation 1. I'm going to graph equation 1 in red. So I'm going to graph it in red. I'm going to start at 4. It has a slope of 1 over 1. Let's see, y is greater than or equal to negative 1 over 1x plus 4. I just put the invisible 1 in there. It helps me with the slope, right? So we'll go down 1 over 1, down 1 over 1, down 1 over 1. Okay, so I'm going to graph the line. Start at 4, down 1 over 1. Now, is this going to be a solid or dash? Solid or dash? Solid or dash? How come? Yes. See that little equals? Yeah, see that little equal sign? So it equals the line. Good job, Carla. So I'm going to make it solid. Everybody agree with that? Now, am I going to shade above or below this line? Y is what? Read it. Y is what? Greater than. So I'm going to shade above the line. So everything above the line. So if you want to get, if it was raining, above the shelter, we shade all that. Okay. How am I doing? Okay. Thumbs up so far. I see 1 thumb up. 2, 3, 4 thumbs up. That's it. Okay, good. Now, the other one I'll put in green, but it's not ready to graph yet. So I'm going to bring over the x. How do I bring the x over? Y is less than a negative x plus 0. 1 over 1. Okay, do this one in green. Start at 0. Down 1 over 1. Okay. Solid or dashed? Dashed because there's no equal sign until I agree. So I'm going to dashed. Am I going to shade above or below? Below. Oh, this is a weird graph, huh? Wow. What do you think the answer should be?
No solution?
Yes. Do they overlap anywhere?
No.
Do they have any points in common? No solution. Didn't trick you, did I? Okay, ready to turn the page? All right. If I get going too fast, will you please tell me to slow down? I don't mean to, okay? All right, now, example 3. It's hard to see because I took it off of a book, but it's like this, and it's like this, Okay, does that help? So it's like Jeopardy. I know the answer. Let's figure out what the question was. Well, I've got line. Oh, actually, this is not down here at all, is it? Darn me. There's nothing here. It starts here, doesn't it? I thought that was the axis. Okay, so I've got equation 1, equation 2. Equation 1, let's see. Equation 1 is straight across. Straight across. Straight across, horizontal. You remember what those are? Straight across, horizontal. Straight across, horizontal. What's this? Y equals what? Do you remember what that equation is? Y equals just 2, isn't it?
Negative
Can I oh, that is the x-axis. Oh, golly, I can't see, can I? Yes, negative 2.
Yes, here's my x-axis. Boy, I'm really confused now. This is correct. So x, so I'm going to say y is equal to negative 2, because that's that line right there. But I shade everything above it, so I'm going to rewrite this as y is greater than, do I have an equal sign on this one? Equal to negative 2. Okay, good. How about equation 2? Looks like I'm going to go up 1 over 1, up 1 over 1. And it starts at what? Starts at, so I got y equals up 1 over 1 x plus 0. And I'm shading below, so what am I going to say? Shading below it? Y is less than, right? And then does it have an equal sign right here? Okay, there's my, and there's my, so these are my two together, which creates this system. Yeah.
Can we put those together like we have like the compound inequality that we used to do? That's like the layout that you made. Is that like the same thing or?
It's different, and that was such a good question. Yeah, and the reason we don't is because we're going to, we shade it on the XY plane, not on a number line. Really good question. I will do this though. How's that? If I shortcut it, got rid of the invisible numbers, right? Okay, example 4, let's do this one, okay? So example 4, graph this system of inequalities. So first of all, I'm going to take equation 1, equation 2. Equation 1 needs to be solved. Equation 1's not ready to go yet. Okay, I like to solve for y. I really do. So equation 1's not ready to graph yet, so I'm going to solve for y. So let's bring the 2x over. Come on, smart kids. Come on, smart kids. I know you're smart. Let's just bring the 2x over. How many are going to bring it over? Subtract. Everybody agree? Subtract. Everybody agree I can skip these steps? I could go minus 2x, but why not just bring it over and subtract? You see that, right? Because at some point in time, you know, you're going to think, come on, Mr. Davies, I get this, right? So I got y is less than a negative 2x minus 1. Okay, I'll shade this one in green. I like colors, so I'll put my negative 1 for my y-intercept. Invisible 1, so I'm going to go, start at negative 1, down 2 over 1, down 2 over 1. Or I can just keep going opposite, up 2, back 1. Solid or dashed? Solid or dashed? Dash. There's no equal, right? There's no equal, so it's a dashed line. Definitely dashed. I'm going to shade above or below? Because it says y is less than, so everything below it, right? Y is less than. Okay, all right, got it, all that. Okay, number 2 is ready to graph. It really is. Number 2 is ready to go. So I start at positive 3. I'm going to go down 2 over 1. Oh, this is another one of those tricky ones. Look at that. Solid or dashed? Right? Okay. And shade above or below? Above, right? Yeah. So there's no solution, is there? Well, I got to fix this worksheet. I got to make one so there at least is a solution, right? There's no solution. They don't overlap anywhere. Wow, okay. The next one has a solution. Let's do the next one, okay? All right, you have at most 8 hours to spend at the mall and at the beach. Oh, honestly, nobody would ever do this on a math problem, but let's do it anyway, okay? So I got my mall, I got my beach. 8 hours at most, so I'm going to say so much time at the mall plus so much time at the beach. At most, 8 hours. You want to spend at least 2 hours at the mall. Okay, so at least 2 hours at the mall. And you want to spend no more than 4 hours at the beach. All right, I can graph this. I've got my mall, my beach. 1, 2, 3, 4, 5, 6. Let's see. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. I'm just doing the cover-up method, right? Y equals 8, x equals 8, right? I'll let you catch up. And again, for obvious reasons, I stop here, right? Could have negative time at the beach. That would be a bad day. Negative time at the beach.
Why do you have to spend that much time?
You're right.
Or
Will you hang on to that
8 hours
question?
at the mall.
Will you ask that question in about 2-3 minutes, okay? Because it's a really good question. So then everything below, right? Yep. No, actually, it's a really good question. Mars, you're ahead of me because I wanted to ask that question, but you already asked it, okay? So then I'm going to shade, okay, so everything below. And I'm not going to shade anything in the negatives because that's not right, okay? Now, x is greater than 2. Looks like this. X is greater than 2 looks like this. And y is less than or equal to, I'll do this in orange. Y is less than or equal to 4 looks like this. And the shading below. So where's the intersection? Do you guys see the overlapping? It's in this trapezoid area. You guys see this? So, Mars, let me answer your question. There's lots of options, right? In fact, if you don't want to go to the mall at all, no, if you don't want to go to the beach at all, you'd be right here. You'd be 3 hours at the mall, no hours at the beach. If you want to be here, you could be 4 hours at the mall, 1 hour at the beach, right? These are all the possibilities. These are all the maximum times that you could be at either, right? But you could peak, let's say you hate the beach. Sorry. I'm not being really sad, you hate the beach, right? But if you hate the beach, you just spend time at the mall, right? But for some reason, you have to spend time at the mall. Maybe you have to grab some clothes for whatever, I don't know. That for me, I would do it the other way. I hate the mall. Love the beach, right? Okay, so questions? So all of this is all the possibilities at either the mall or the beach. Homework today, and we do have time to get some of it done. Page 155. 1 to 12 all. Okay, and that's it.